You can see here molecules of oxygen and carbon dioxide. This type of model shows you that these molecules take up space. They're not flat, they take up space. Polar molecules are molecules that have charges. The charge results from electrons being held closer to one end than another. So here, oxygen kind of pulls the electrons away from the two hydrogen atoms. So this pull is slightly negative. The hydrogen loses its electrons to oxygen to some extent. So the electrons are more toward the oxygen than the hydrogen. So each hydrogen has a slightly positive charge. This results in a pole, positive and negative poles, and this is due to polar covalent bonds. Which of the following elements will form a polar covalent bond with oxygen to form water? Hydrogen. There are three states of matter on this planet: solids, which maintain their volume and shape; liquids, which have a constant volume but no fixed shape; and gases, which have neither a constant volume nor a fixed state. Water is a unique substance. It is the only substance on our planet that it can occur in all three states of matter: solid, liquid, and gas. The hydrogen bond is a very important part of the water molecules on our planet. Hydrogen bonds are attraction between the negative and positive poles on different water molecules. The negative oxygen of one water molecule is attracted to the positive hydrogen of another water molecule, and it holds them together. So many water molecules are held together to each other by hydrogen bonds. These bonds are very, very weak, but there's so many of them that they have an influence. It holds the molecules together, so it's difficult for the molecules to escape, such as when you're boiling water. From water to go from a liquid form to the gaseous form, that water at the surface must escape into gaseous form, but because of those hydrogen bonds, it's held quite tightly. Here you can see the attractions. It is the positive attraction of a hydrogen and the negative attraction, the negative charge of the oxygen that holds them together. So right here is that very weak hydrogen bond, but you see there's just so many of them. It causes water molecules to stick together. When water molecules stick together, organisms can walk on the surface. This is called surface tension. Which of the following is the basis of surface tension? Hydrogen bonds. Water is a solvent. Those charges on the ends of each water molecule, they're polar charges, remember, negative oxygen and a positive hydrogen, allow water to pull apart ions in an ionic compound and dissolve them. We want to talk a little bit about metabolism. Metabolism are all the reactions that take place in the body. There are two types of reactions. You either make a bond or break a bond, and that's called a chemical reaction. So you have reactants coming together and forming a product. And we usually express this as a formula that we'll see later. So each cell is a chemical factory, and all the reactions to keep it alive take place in the cell. It has to take in energy molecules for our body, that would be glucose. It has to convert that glucose to ATP, which is the energy battery molecule. It has to maintain the cell, repair the cell. The cell will grow after it divides, The cell has to secrete substances and take in substances. There are many different chemical reactions that all require energy. Work is the movement of an object or change in the physical structure of matter. So work, running around the block is work. Building molecules is changing the physical structure of matter. That's work. Converting liquid water to vapor or evaporation, that is work. Does work require energy? Think about these different examples of work, and each one of those does require energy. So energy is defined as the capacity to do work. There are two different kinds of energy: the energy of motion, kinetic energy, or the energy that is stored. For example, your breakfast has molecules that are stored energy, and in our body we release that stored energy. When we eat our breakfast and convert that stored energy to the energy of motion, some of that energy is released as heat. We are warm bodies. So those energy conversions are never 100% efficient. Some energy is lost as heat that cannot be used. What term is used to refer to stored energy? Potential energy. Chemical notation is how we write chemicals, how we write formulas, and we just do some basics here, so please don't worry about it. Here you can see H with a 2. This is called a subscript. It tells us that there are 2 hydrogen atoms. This together, these 2 atoms, is the hydrogen molecule. We can see the same with oxygen. There are 2 hydrogen atoms. This is the oxygen molecule. And H2O tells us there are 2 hydrogens and 1 oxygen. That's no surprise to anybody. Well, a chemical reaction, and down here at the bottom you can see this chemical reaction. We have hydrogen and oxygen forming water. The reactants are on the left-hand side, so hydrogen and oxygen are reactants. The product, what we're forming, is water. The arrow points to the product, or the direction of the reaction. Superscript, we'll see this when we look at ions. So ions, think of electrolytes, those substances that you find in Gatorade. You might find sodium in Gatorade, you might find potassium in Gatorade, or manganese in Gatorade. So here's a sodium atom, and it has lost an electron, so therefore it has become the sodium ion. It's lost only 1 electron, so its charge is +1. Sometimes an atom gains an electron. It's still an ion. In this case, it's a negative ion or anion. Chlorine, when it loses an electron, becomes the chloride ion. Calcium has a +2. In this case, there has been more than 1 electron lost. 2 electrons are lost for each calcium atom. Chemical reactions rearrange atoms in new combinations. Well, here we started out with hydrogen, and we start with oxygen, and we form water. But the number of atoms on each side of the equation, each side of that arrow, must be the same. And that's called balancing the equation. You do not have to know how to balance equations. We've already talked about the superscript with ions, positive and negative ions. You may know the answer to this. Which of the following is true of each side of a balanced equation? The correct answer is B. We have to look at the different types of chemical reactions. Remember, a chemical reaction is just making a bond or breaking a bond, and the first one we're going to look at is decomposition. So you know something is breaking down into smaller components, decomposing, breaking, such as digestion, and you're going to have your initial molecule, your reactants, breaking down to form your two products. We call this hydrolysis because in order to break this AB molecule down, we need to add a water molecule. This allows this molecule to break down into A and B. Hydrolysis means water breakdown. It is a decomposition reaction. A generic term for decomposition reaction is catabolism. So some examples of catabolic reactions are digestion, the breakdown of glucose to form ATP in the mitochondria. The second type of chemical reaction is synthesis, that is combining atoms to form a larger molecule. Here A plus B are the reactants, AB is the product. With the last one, with decomposition, we added water to break it down. Now, to build, we take away water. Therefore, it's called dehydration synthesis. We are taking away water to build a new molecule. Dehydrate is to remove water. Synthesis is to build or to make. A general term meaning all of the synthetic or building reactions in the body is anabolism. Decomposition and synthesis reactions are often coupled together. This means that as one compound is decomposed, the energy from that reaction may be used to build another compound. Often these reactions are reversible. So if you see this arrow, A plus B forms AB, the arrow's moving right, or A plus B forms A plus B, you can just reverse this arrow. At equilibrium, the rates at which both reactions take place is the same. The exchange reaction we don't have to worry about, where reactants are shuffled. If you just look at AB becomes AD. So the B replaces the D. They kind of switch places. An example of this would be acid plus base forms salt and water. It's a neutralization reaction, but again, don't worry about exchange reactions. Which of the following does not represent a decomposition? Therefore, it must be a synthesis or building. The correct answer is D, dehydration synthesis. The other three are all breakdown or decomposition reactions.